Good afternoon, my name is Michael Stavlin. This module was created for Agricultural and Biological Engineering 425. Today we're going to be discussing Thevenin equivalence. So in this diagram that we have presented here, we notice that there's a lot of elements that might make it confusing to determine the voltage, the current, and the equivalent resistance of it. So what we're doing as part of Thevenin equivalence is trying to simplify this circuit. Ultimately, what we're going to be doing is isolating the current source, the voltage source, and the resistors labeled in the diagram to derive something simpler. So what we'd like by the end of this is to have a voltage source, a single resistor, and open ends so that we can analyze these three factors mentioned. We're going to go through in a step-by-step process. First, we're going to identify which portion of the circuit we can eliminate. Then we're going to determine the open voltage, and that's going to be done through a process called superpositioning. Next, we're going to look at these two resistors here to combine them so that they're ultimately resulting in a single circuit. And then we want to finalize our product with a new resultant voltage and Thevenin equivalent resistance. So we'll go through this in a step-by-step process. The first thing we want to do is give ourselves a perspective on where to look at this circuit. So you'll notice that a point A and a point B has been drawn around the R element. What the objective of this is to give ourselves a vantage point in looking at the circuit so that we can understand where the voltage and current are going through the different elements that we're going to ultimately simplify in the final result. So by removing this RL element, we look at the circuit through A as an input and B as an output. So again, the important thing to realize for Thevenin equivalence is that you're trying to simplify it and you want to look from this single perspective into the circuit to gain some understanding of what's actually happening. An important thing for calculating Thevenin equivalence is that you notice we've eliminated our original voltage source here. We've made it a short. This is important to note because as opposed to current sources, which you'll notice here, have been left in an open circuit, we're going to be able to interpret the circuit differently from this perspective. So important note in step 2 is that we want to short the voltage source and we want to leave the current source open, much like what we did here for our RL element, but again, this is our vantage point. So we realize immediately that no current is going to go to this part of the circuit, but rather it's all going to go to this part where we have our two resistors that we're ultimately going to connect. So in this superpositioning method, what we want to do is analyze each part of the circuit independently. So the first and easiest thing to do is to realize that we had a voltage source here. And now since this circuit is drawn just as a regular wire, we're going to calculate what our voltage across this perspective is, as mentioned before. So to do that, what we want to realize is that we have this R2 resistor in parallel with this voltage source. So realizing, again, our vantage point is here, and these being in parallel, because we're dividing the circuit at this point, we want to note that it's going to be R2, the single element that we're analyzing across, over R1 plus R2, as we've done in previous modules. And ultimately, since this is just a resistance and we want a voltage, we want to be multiplying by this original voltage source that we had here. So this is half the battle because we're only analyzing in this understanding of the circuit from this perspective again, what's happening with respect to the voltage source. Now with respect to the current source, we're going to do something similar. But we want to analyze it instead of using the voltage source with that current source. So realizing that the current source was here before, we want to use this as a substitute for our voltage source. And we want to realize that, again, these resistors are in parallel. So what does that mean? If the resistors are in parallel, we want our product over our sum as we've discussed before. So that would look like such. R1, R2 over R1 plus R2. Now ultimately, because we're analyzing these superpositions independently, our new open voltage source is going to be the combination of these two. So when you solve for this Thevenin equivalent, you want to realize that the first step is to solve for this open voltage source, and it's going to be the combination of these two elements that we analyzed independently.